Okay, well this talk could be also called Cropping Management in the Age of Big and Other Data. So I'm not really going to talk so much about big data, about farm data, and I'll kind of work through some of the things around big data and what it means. And then I'll finish up by taking a look at some of the data flow that's currently can come off a farm and how we can use it. I work for a company that's Farmer's Edge. This is the business we're in, a mix of agronomy, hardware, software, data analytics. I'm going to talk about our solutions a little bit and use them as examples. We're not the only game in town. It's a market that, there's different solutions being developed by different vendors or and using slightly different approaches. There's this company called Climate Core that's owned by another little company called Monsanto that's a major player in the game. There's quite a few out there. We're a Canadian company who I think is, we're taking a little different approach than someone like Climate Core, and I think we're making pretty decent progress. This just kind of maybe a bit of a tie-in to this morning. Yeah. If you look at those dotted lines, the solid lines, that's the growth in, growth in production, global production. The solid line sort of progressing forward into the future. The upslope sort of dashed line, that's where we actually have to be to meet market demand in those different grains and oilseeds. So if we just stay on the same slope, we're not going to make it. There's another thing at play, and this was kind of touched on this morning in the Alberta context, but it's in the global context, is as Will Rogers said, 50, 60, maybe more than that, 100 years ago almost now, buy land they're not making anymore, right? So to meet that upslope on the dashed line, to meet that upslope on the dashed line by expanding agriculture, crop production, we would need about 250 million more hectares of arable land. And I mean, unless we've missed some continent about the size of North America somewhere, we just don't have it. There's just not, it isn't there. And the land that could be expanded onto for agriculture tends to be tied up in different, it's being used in useful ways now, whether it's, pastoral systems, natural systems, wetlands, I mean, you name it, it's providing a lot of ecosystem goods and services. So from where I come from, intensification of agriculture on the existing land base is part of the solution. Intensification is not the problem. So we have to do it intelligently, and it's going to happen. And actually, the UN and groups like that tend to agree with that idea. There's been 3 big revolutions in agriculture, or 2, and now there's 1 starting. First one was the Green Revolution. So, improve varieties, improve systems, in chemical fertilizer inputs, herbicide, pesticides, ran through, it's still going on, but it ran from the 50s through to the 90s. Major increases in the productivity of major crops. The next one was the GMO revolution. And so, GMOs started to make traction in the 90s. They revolutionized the canola industry in Canada. They've revolutionized the corn industry in the U.S. Okay. This little graph is a meta-analysis that was done a couple of years ago about the impact of GMOs. And you can see here, this is over many studies, right? Yields up, pesticide quantities down, pesticide costs down, total production costs pretty neutral, and farmer profits up. So a second revolution that's still underway, that's run into quite a bit of issue, but GMOs have made significant contributions to improvements in our agricultural systems and increases in productivity. The third one and that's the one I'm going to talk about a little bit today, that's just starting, is this what I call the big data revolution. And what that is there's a opportunity to collect data from farms and from other sources and use it to improve management systems on the farm. Okay, so you can collect data from 1,000 farms and analyze it and use it to make predictions about what will happen on a particular farm in a particular field if you do a certain thing, okay, with a certain level of probability or certainty. So big data, the real trick to big data, or the why people are interested in it, is because we can start to use it for its predictive capability. Now, this is going on all around you. You know, every time you use your cell phone, some of that data is finding its way into somebody's data set that is being used in some way. You go onto Amazon and click on anything under Amazon, and it says, would you also like to look at this? Those are big data algorithms working in background to try and figure out what your interests are, what you're up to, okay? So I would say probably 95% of big data right now is being used to try and sell you something. And I suppose we're really no different. But I was at it's interesting, that little building down there. I got a phone call from this woman in Texas about 2 months ago. She said, do you want to come to a beers conference? And I said, beers? Yeah, sure. Are there samples, right? What it was actually was BIRS, which is a little institute here for advanced mathematics. So I went to this big data mathematics conference. Like, I'm a soil scientist, right? So I get in this room down there for a Saturday with 25 guys and gals with PhDs in mathematics, advanced statistics, those kind of things. If you've ever wanted to be in a situation where you absolutely know you're the dumbest guy in the room, right? It was really interesting. It was kind of like watching a foreign movie with subtitles. Like, I kind of got it, but I know I wasn't really getting it all. Anyways, so keep this moving, because I always talk too much at the beginning. So what is big data? I mean, really simply, big data is data from a whole bunch of different sources that potentially that is just too big and too complex to manage using Excel spreadsheets. I mean, that's the easiest way to put it. So you can't organize it in the ways we were used to 15 years ago, where we would put everything in a relational database and work with it there, okay? So you have to use different techniques for storage, different techniques for management, different techniques for analytics. And they talk about 4 V's in big data, and that's, you know, volume, velocity, variety, and veracity. So one of the things about big data is, well, there's lots of it. Now, ag data, I mean, we're big data in a sense because of complexity. We're really not big data in the sense of, you know, massive volumes compared to some other areas. But we do have, you know, that's growing. Velocity is data is starting to come at us at a really fast rate, and a lot of the things you can do with data are time sensitive. So the whole thing with trying to use data that's flowing off the farm or from other sources is to develop actionable intelligence out of it. Develop something that can help a producer or somebody else in the chain make a decision, right? And some of those decisions have to be made really quickly. Like, you know, I've got a disease risk in my field, what do I do about it, kind of thing. Or better yet, we've identified a disease risk in your field, here's what you can do about it. Some of them are longer time, like longer time frame. How did my fields do how did my canola fields do against one another and against the rest of the canola fields in Western Canada? And then, I mean, one of the other things that happens is veracity is, you know, what's the value of data if it's basically it's the old garbage in, garbage out. So, you know, there has to be checks and balances on the veracity of data. You can't take it all at face value. So there's a different skill set then for this kind of thing. So it's, you know, you need to have, like, I interact now a lot with computer scientists, with mathematicians, with statisticians, and here's what what I can't do is I can't figure out how to ask the questions of the data. They can figure out how to ask the questions. What I can bring to the table as an agrologist and an agronomist is they don't know what questions to ask. So if we give them the question, they can ask it in clever ways, but they don't know what questions to ask. So it's very much an interdisciplinary team that needs to work on this. There's about 0.5% of the data that's collected in the world, and I don't think ag is a whole lot different. 0.5% is actually analyzed in some meaningful way. The other 99.5%, data people refer to that as dark data, right? So there's this whole big chunk of data out there. Lots of it's been captured and stored, and nothing's been done with it yet, or maybe never will be. There's also, if you think about a farm, there are drills going out there in Western Canada right now that the actual data is flowing through the drill about all kinds of information about how much they're applying at each location in the field, those kinds of things, of seed and fertilizer, but it's not being captured. It's kind of flowing out and gone, right? So in the ag space, or in the crop production space, we can take data from a whole bunch of different things. There's public data, there's decision tools and research that comes out of academic institutions that give us ways to interpret data, manage data, and then there's data from the farm, from the market, those kind of things that we can pull in as well, okay? What we're really after there is developing a set of what we would call robust decision support tools. So what we want to do is capture that data, process it in interesting ways, draw knowledge out of it, and feed that back to the producers so they can take advantage and make better decisions. Those decisions can improve their economics, but they can also improve or minimize their environmental impact. So I think this is one area where we can have a win-win on environmental and economics. Now, one thing I will say is, like a lot of the stuff that's being developed in the U.S., if you start to follow this, right, it's being developed in a data-rich environment. There's a lot of public data in the U.S., right? A lot of it's freely available. Canada is not a particularly data-rich environment, okay? There's not actually a lot of public data available on a lot of things that would be useful. When it is available, it's available at a scale that's typically too big to be useful. The other thing that the problem with it is quite often the data is collected and processed and made available where you could start to move it into some of these algorithms that have been developed, but it isn't released in a timely manner. So the processing time, for example, within the public system doesn't meet up with the decision timeline during the growing season. So we're kind of left then to start to capture our own data from the farm and figure out how to do this on our own. And so we, as in my company, plus a bunch of other companies, have gone down this route and have started to develop the hardware, software, and the hardware, software, agronomics, data management systems, and analytics systems to do something with this. So let's take a bit of a look at what farm data, I give you a bit of a quick tour of it. So you've got all this external data, but then you've got a whole bunch of data that's generated on the farm that's useful for decision making. That could be field history, yield history, the varieties you've grown, those kinds of things, your input history, right? And you can start to combine that on-farm data with some of the historic data you do have access to, okay? And one of the big sources of historic data is actually imagery. And in the last few years, one of the things that's happened is imagery companies, and by this I mean satellite companies, have started to really look at their business model and think through new ways to get their inventory into play So the old model of 5 to 10 years ago was we take all this imagery from satellites, like massive amounts of it, and then you come along and you say, I want to look at this particular little piece on this particular date range, and they sell you those images at extremely high prices, right? And the rest of the imagery that they've got to collect, because satellite goes over and over, they have collected, it goes into some data store and it basically stagnates there. So a lot of the imagery groups have started to develop systems then where for fairly reasonable prices you can get into their image libraries and start mucking around with them, okay? And they've developed the tools to access them, to query them, those kinds of things. So that's been a fairly significant change that's coming. The other thing that's happening in this area, the other thing that's been happening in this area is there's new sources of imagery coming down the pipe. So, like if you're used to working with something like RGB and a little bit of infrared, there's new systems coming down that will provide hyperspectral imagery at fairly high resolution and low cost. Once you get into that kind of, first of all, it multiplies the amount of data you have to deal with exponentially, but it also multiplies the opportunities exponentially as well. So the other thing you can do then is you can start to use that data to start to make some assumptions and some inferences about productivity. So one of the ways to do this, one of the simplest ways to do this is to use NDVI, normalized difference vegetative index, to look at that over a period of years and figure out which parts of the field tend to be higher productivity and which parts tend to be lower productivity. So you can start to build, I say, kind of a productivity map over the field. One of the other things you can bring in that starts to help you understand that productivity map is weather data. So you can start to get weather data that's gridded to 1 kilometer. Historic weather data. Now that certainly helps, but when you start to get into weather data that you want to use in this growing season, a gridded system that's based on stations that are 50 kilometers apart isn't much use. And so one of the things we've done is we've started to put out weather stations strategically located in farms. So we've got a network of 1,000 weather stations across Western Canada located on our farmer groups. We're not the only ones doing this, right? But what it gives us is it gives us this proprietary weather data set that we can start to make better predictions, or not just better predictions, but we can start to keep track more closely about what's going on in any particular field in terms of things like precipitation. We can start to work that into the mix of how we interpret data and how we develop decision support systems. What we're leading to on this is coming up with using things like historic weather data, imagery, yield. If a farmer has decent yield maps, we can start to push this then into yield modeling on yield modeling data, and then from there we can go to some ground truthing. This is one of the things that I think is a really important part of the equation. You can use imagery, but unless you do a certain amount of ground truthing of that imagery, you're not really sure if what you're looking at in the image corresponds with what's happening on the ground. So ground truthing, I say, whether it's things like soil sampling or field inspection on a certain percentage of your acres, is an important part of the mix. So that kind of gets us then to thinking up new and clever ways to do things like input modeling. So one of the things, though, with modern equipment now is you can start to collect data off the equipment about what's actually happening. So what's happening sort of geospatially and in time as inputs are applied okay, as the crop develops during the course of the year. Okay, you know, with things like satellite imagery, you can track that. And where we can get to with that by combining things like weather data, imagery data, and as they say, is we can get to things like reasonably, they're probabilistic, but reasonable yield forecasts at mid-season. We can't forecast a hailstorm 4 weeks from now, right? But what we can do is get to the point where we say, based on what we've had in terms of weather, what we can see in terms of biomass development, what we know probabilistically about weather for the rest of the season, we can make some pretty reasonable forecasts about what kind of yield you're going to get at the end of the season, and what kind, that starts to provide decision or information for decision support on how you're going to manage the crop for the rest of the season. And then finally, we can get harvest data as well. So, you know, we can pull data off the combine into a system, and then the final analysis at the end of the season is then we can go through sort of field by field, area by area of the field, and provide growers back information on their economics. So now there's a couple of tricks to this, right? One is you have to move to a passive data system. One of the things that the industry has learned the hard way in the last few years is that farmers will not input data. They just won't. Okay, so you have to move to passive data systems, collection systems. So this is, you know, this is ongoing. There's hardware. John Deere, for example, has hardware that uploads automatically. We have hardware that we've built that is sort of doesn't care what color the paint is, that uploads automatically. So you have to start bringing that farm data up into your system passively, or it's kind of a non-starter. The other thing is you have to have scalability on this to do some of those things we're talking about, right? To predict what's going to happen at the end of the season in that one canola field, we have to have the data from 10,000 canola fields. Okay? So you have to be able to scale this. The other thing is, because these data sets, I mean, they're not huge by Google standards, but because these data sets are big, and you want to turn them around quickly, you have to go to automated processing. And then from automated processing, you go to automated decision making. And then the last thing, and this is something that just makes some of our farmers really get hooked on this, right? Is benchmarking within the field, within, you know, across a, you know, peer set, and they want to know. They want to know how their canola fields are doing against each other. But then they want to know, find me 50 growers that are like me and tell me how they're doing. You know, how am I within that mix, right? And again, you have to have a certain volume of data to deal with that. The other thing, and this is, you know, you never know what makes farmers really, you know, get up and take notice. But benchmarking, we kind of piloted this with a small group of farmers last year, where we collected the equipment data. So how much fuel they were burning, how fast they were going, how much they were putting through the combine, and started to build up productivity benchmarking between different combine sets, right? So now this is kind of a, you know, this is kind of very, I mean, farmers were really interested, and someone had 3 different colors of combines, and it was like, oh wow, you know, like that one does way better than, you know, those other 2. So they're keenly interested in this for decision making, and it would be really interesting, I think, in the years ahead to see that kind of, not just crop benchmarking, but equipment benchmarking starting to take hold. So I'll leave you with this last thought. We work with that data and the farmer. Our deal with the farmer is you own the data that's specific to your farm, and when you come on with us, we own the rights to aggregate that data, right? So we can use it in aggregated form as long as your privacy is protected. You can't be picked out of the mix, right? But we also have to be really careful, and that's because there's a lot of people want to know this data. One of them in particular that we've done, we've had a lot of interaction with is the supply chain, the food chain, food supply chain. And so they want to know what's going on in the farm. And so, and they may have the power, because they control the supply chain, they may have the power, they do have the power to tell the farmer to let them see, right, to be more transparent about practices on the farm. And I can see, 10 years down the road where data transparency or practice transparency really on the farm is going to become something that is just table stakes to get into the supply chain.